The following is a demonstration by the West Semitic Research Project of the University of Southern California to show the interaction of two technologies that we would like to use in the Kitzel Caves in China. One of these is panoramic photography, specifically that done by Panoscan cameras. The other is Reflectance Transformation Imaging, or RTI, which allows light interaction by the user. The first image I have here is a very high-resolution Panoscan image, and I show this to show that the detail can be very, very good even in the Panoscan image all by itself. These are very high-resolution cameras that are taking the images. And we can move in and out, of course, to show close detail, and back to show a larger view of the room. As in all panoramic photography, of course, one is able to move around 360 degrees and see every aspect of the space, but also to get a fully spherical experience by going up, straight up, and then straight down to the floor, to see every aspect of the space. In this particular Panoscan image, we have pasted in flat images of various objects that we are going to be using as hotspots to connect to simulations of RTI images. As we look first at this one, this is an image that was taken in the Metropolitan of one of the Kitzel Cave paintings. We can see that the user can move the light from any direction. One can also zoom in to look in more detail and apply transformations which enhance the texture data of the image. In this particular case, we can see that in the applying of the paint, the background displays longer, more regular paint strokes, and then other paint strokes were applied over it to give the detail and line around the various figures, and one can even get a sense of the dimensionality of those paint strokes. In this second image, another painting from a Kitzel Cave, one gets a very good idea of the conservation data, and then one could see where the paint has chipped away from the wall. Also, as one zooms in and moves the light around, and in this case applies a transformation called diffuse gain, one can begin to see the dimensionality of the little dots around the face in the halo, and very, very detailed texture data. So we get detailed data not only about the background, but also about the painting itself.
Hi.
As we move around the room, we come across other images. In this case, we have a Dead Sea Scroll fragment done in soft media with a flash. And as we look at this in detail, one can see, as one moves the light around, information about the texture of the background. However, it becomes even better when one can apply specular enhancement, and one can see also the dimensionality, the thickness of the ink. And we believe we can even see the order of the ink strokes that have been applied to that very textured background. And again, the user is the one who is controlling the transformations and the light. Reflectance Transformation Imaging is especially good with incised objects, in this case an Egyptian funerary stela. But even in regular light, one misses a lot of detail. And so specular enhancement allows us to see detail that we might otherwise miss. It makes the object look like it's dipped in silver. And in this case, one can see the facial features of the small child in front of the woman that one might miss in regular light. In addition, one can also apply two separate lights. This is a very good way of creating what we call a key and fill situation, where we have a dominant light and then a lesser light. The green light represents one light, the red dot the other light. And notice I have turned off the green light, turned it back on again, turned off the red light, turned it on again, to show that each light is providing a different angle and different data. And then one can zoom in, move the light around to give exactly the kind of detail that one needs. We have used this kind of technology very effectively on other kinds of paintings. We have here a mummy mask from Greco-Roman era in Egypt. And in a regular light, it looks rather flat. But as one zooms in and applies transformations, one can get very detailed data about how this was actually painted. In this case, we are applying specular enhancement, and we can see the long brush strokes to the right on the background, and then the way the paint is applied on the face, and we can see that it is different and may have been applied with a finger or perhaps a stick, something very much like a modern palette knife. If one then goes in and applies diffuse gain, one can retain that same sense of detail, but also color, so one can see how the various color pigments were applied and perhaps any differences between them. Finally, we have a painting on wood. And in this painting, you not only have the use of the paint for paint strokes, but you also have a lot of texture that has been used in order to highlight the halos around the faces of the figures, around the shield, around the helmets of the soldiers. And specular enhancement really shows that texture data very, very well. One can also see in the background the crackling of the paint or perhaps cracks in the wood. So again, a good combination of the study of conservation information, but also how the painting itself was done, the techniques that were used. Now, the combination of these two techniques is still under development, but it shows what we would like to be able to combine in the Kitzel Caves in China. We think this is a very effective way of not only presenting both overall data about a cave itself, but detailed information about the paintings within it. We also foresee a way in which paintings that have been now lodged in different parts of the world could be sort of attached to the Panoscan, and so the researcher would be able to see those paintings in their original context by an internet database application. Thank you.